Hello and welcome back to 6th grade math support. My name is Dr. Griggs and these are our topics for this school year. We are now on the second topic, which is the number system. Inside of this topic, we do have a total of 13 objectives. So let's check out our objective for today. For today, we have find the greatest common factor of two whole numbers less than or equal to 100 and the least common multiple of two whole numbers less than or equal to 12. Use the distributive property to express a sum of two whole numbers, 1 through 100, with a common factor as a multiple of a sum of two whole numbers with no common factor. So we will not do all of these. We'll do the first one just to get an example of the greatest common factor. And I may bring in just another small one that we can do for finding the least common multiple of two numbers that are less than or equal to 12. And that will give us a good example of what this objective is asking for. So let's look at our example for the greatest common factor. We have a community garden project. A community garden is preparing two planting beds. Bed A has 60 tomato plants. Bed B has 84 pepper plants. Greatest common factor. The gardeners want to arrange both types of plants into identical rows with no plants left over. So the question is, what is the greatest common factor, GCF, of 60 and 84? How many plants will be in each row? So the answer to this question is going to also be the answer to this question of what is the greatest common factor between 60 and 84, because at that point, that's going to be when they can have identical rows with no plants left over. So let's see how we can figure this out. So we're looking at 60 and 84. So we're also looking for the greatest common factor, or GCF. So that means we need to list out the factors. One way to do this is to list out by factor pairs. Just in case you don't know them in order right off, you can always do factor pairs and then put them in numerical order. So for example, I know for sure that 1 and 60 are going to be factors because it's always going to be that number times 1. That's always going to be a factor pair inside of every single number. So now let's think about 2. Well, 2 can also go into 60. It can go in there 30 times. So we're also kind of thinking about it as division as well, because we're trying to see how many equal groups of that number can go in, which will also lead us to the factor pairs that lead up to that number. So now if we think about 3, well, 3 can also go into 60, and 3 times 20 will give us 60. Well, let's think about 4. Can 4 go into 60? So because I said we can use division, let's do that with 60 and 4. So we can see how that will look, because let's say we don't know if something is a factor of another number, we can do division. If it leaves us with a remainder that is not a factor of that number, it has to be 0 remainder in order for it to be a factor of that number. So let's see, 4 goes into 6 one time. 1 times 4 is 4, and 6 minus 4 is 2. I'm going to write it down here because I'm just going to blend in with that and bring the 0 down. 4 goes into 20 15 times. So this leaves us with a 0 remainder, meaning that 4 and 15 are indeed factors of 60. Now, let's think about 5. Well, because this number ends with 0, If the number ends with 0 or 5, we know that 5 is also a factor of that number. So that means we also know that 5 will be a factor of 60. Well, 5 times what gives us 60? Well, 5 times 12 gives us 60. And we can also do 6. Well, 6 times what gives us 60? 6 times 10 gives us 60. Now we have found all of the factors for 60. Let's do the same for 84. All right, so we know right off it's going to be 1 and 84. Because this is an even number, we also know that 2 can go into this number. How many times? Well, 2 goes into 8 4 times. 2 goes into 2 2 times. So 42. Now, 3. Let's say I don't know. So let's use this as an example of testing whether or not a number is a factor. So 3 goes into 8 2 times. 2 times 3 is 6. 8 minus 6 is 2. Bring down the 4. 3 goes into 24 8 times, and that's going to be exactly 0. For a remainder, that means that 3 and 28 are also factors of 84. Well, let's think about 4. Well, if we think about each number, we do know 4 can go into each number, therefore it can go into this number. 4 goes into 8 2 times, 4 goes into 4 1 time, so 4 times 21. Now, this does not end in a 0 or a 5. That means 5 would not be a factor of this number. Well, let's try 6. So let's try 6. 6 goes in 8 1 time. 1 times 6 is 6. That's 24, and that's going to be leaving us with a 0 remainder. So that means 6 and 14 are also factor pairs of 84. Well, let's try 7. 84 divided by 7. That's going to give us another one that does not have a remainder. So that means 7 and 12 are also factor pairs of 84. And we have completed our list. So now the question was the greatest common factor between 60 and 84. So we're looking for the biggest number that they have in common with their factors. Well, this is a little easier when it's in numerical order. So let's go ahead and do that. We have 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. Now we have 1, 2, 3, 4, 6, 7, 12, 14, 21, 28, 42, 84. Now, if we look at the numbers here, it looks like 12 will be the largest one that they have in common. So that means we would have 12 plants in each row. I hope this was helpful to you on being able to break down greatest common factor. And this is the reason why I only wanted to do one part of that objective, because sometimes, I really want to make sure that the information makes sense and not just throw a lot of things out there just for the sake of it. So if you have any additional questions or any other problems that you would like help solving, please don't hesitate to let me know. Thank you so much and have a great day. Thank you so much for joining my tutoring session today. If you enjoyed the way that I instruct and you think that I would be a useful addition to your student or to yourself, feel free to scan this QR code. It is going to take you directly to my profile page where you can get set up on weekly classes with me. Looking forward to seeing you in the classroom.